And the other measure we can use is Gini index. This is used with the algorithm CART. This is the equation for calculating the attribute selection measure. Gini of T is calculated using this particular equation, that is 1 minus sum of I equal to 1 to m P of I square. This is the equation for calculating Gini index. Then we can calculate each Gini index value for attribute, and finally we will get a Gini index value of that particular attribute as the Gini index value of the entire data set minus the value of that particular attribute. Only the equations will change, the procedure and everything is similar. I have presented one example here also based on the same equation, based on the same. You can go through all this, and finally we have to prune the tree. When a decision tree is built, many of the branches will reflect anomalies in the training data due to noise or outliers. Tree pruning methods address this problem of overfitting the data. So tree pruning is also a necessary step that will avoid the problem of overfitting the data. Such methods typically use statistical measures to remove the least reliable branches. An unpruned tree and a pruned version of it are shown in figure in the next slide. Pruned trees tend to be smaller and less complex and thus easier to comprehend. They are usually faster and better at correctly classifying independent test data than unpruned tree. This is an example for tree pruning. An unpruned decision tree is represented in the left side, and pruned version is also represented here. There are two common approaches to tree pruning. We are not going into the depth of this. There are two techniques called pre-pruning and post-pruning, and different algorithms use different approaches. The cost complexity pruning algorithm used in CART is an example of the post-pruning approach, and C 4.5 uses a method called pessimistic pruning, which is similar to the cost complexity method. So just understand these are the different approaches for tree pruning, and this will help to avoid some issues regarding the decision tree we have developed, that is mentioned in the next slide. And decision trees can suffer from repetition and replication. That's why we need this pruning. So this is an example for such a case. We may have repetition, and we may have to suffer from replication. Repetition, where an attribute is repeatedly tested along a branch of the tree. Here, for example, age less than 60. If it is the case, yes, and we have to check whether it is less than 45. But again we have to check whether it is less than 50. That is a repetition, and we may suffer from replication also, where duplicate subtrees exist within a tree, such as the subtree headed by the node credit rating. So these are the some problems with decision trees. So we can avoid all this by using the